Alright, welcome everybody. So today I'm going to talk to you about how to name hydrocarbons. So we've been building up to this moment in time here. We have talked about hydrocarbons, the different types. We have talked about saturated and unsaturated. But now I'm going to actually show you how to name the different types of hydrocarbons. Remember, there are three types of hydrocarbons that you are responsible for naming: alkanes, alkenes, and alkynes, and they have a general formula depending on their homologous series. Alkanes 2n plus 2 for the hydrogens, alkenes 2n, alkynes 2n minus 2. This table in your reference table, table Q, gives you an example, one example, using 2 carbons. They also tell you how the prefixes go for each type of carbon chain. So for example, F has 2 carbons, and so you'll notice that if it's an alkane, it'll be ethane. If it's an alkene, it would be ethene, and if it was an alkyne, it would be ethine. You can also see the difference. This has single bonds, this has a double bond, and a triple bond. Now it's important to note that there's only one double or triple in the alkene and alkyne respectively. If there was 2 double bonds, it would actually be called a diene, meaning 2 double bonds. But we really don't get into naming those. You don't have to know those. So the prefixes tell us how many carbons are in a carbon chain, and then the ending tells us if it is a single bond, a double bond, or a triple bond. So we have meth for 1 carbon, eth for 2, prop for 3, bute for 4, pent 5, hex 6, hept 7, oct 8, non being 9, and dec being 10. Now I have never seen them on the regions go above octane, but you never know. There's always a first for everything. So we have the basic ideas of, well, how to recognize them. We can use this table and we can apply what we did, yesterday to naming these compounds. So the first would be a 3-carbon chain. Let's go through the general formulas and see which one it fits. So C3 would be prop, but I have to figure out, is the ending ane, ene, or ine? Well, I use the general formula, and I see that it fits an alkene because it's 3 carbons and then 2n, which would be 2 times 3, 6 hydrogens. That follows the general formula for an alkene. So now I can draw my structure. My structure would be 3 carbons. The double bond I can put either between the first and second or going the other way, the first and second. I'll put it on the left here. I now fill in the hydrogens in order to get the total number of 6. The carbon on the left can have 2 hydrogens. That will give it 4 bonds. The carbon in the middle already has 3 bonds. It can take on 1 more hydrogen. And the carbon on the end can take on 3 more hydrogens. That gives us a total of 6. This is an alkene, and it's unsaturated. This would be called propene. Now let's try something with 4 carbons. So now if I plug it through the first formula, C would be 4. That should have a total of 10 hydrogens if it was an alkane. Doesn't work. Let's try it for the alkene. Times 2 would give us 8 hydrogen. Doesn't work. The alkyne times 2 would be 8, but minus 2 gives us 6, and that does work. That tells us that this is going to be an ine. We're going to have our 4 carbons. We're going to put in our triple bond. We're going to fill in the other spots for hydrogens. On the left, 1. The second carbon gets no hydrogens because there's no place to put them. It already has 4 bonds. The third carbon has 2. The last carbon has 3. This would be called bute for the 4 carbons, butine. Now, this one gets a little bit more complicated because we need to say where the double bond is. For example, I could have put the double bond here and then filled in the hydrogens. This would also be butyne. The problem is that in the first case, it's attached to the first carbon, it would be 1-butyne. In this case, it's attached to the second carbon, it would be 2-butyne. So I need to say what it is, where that triple bond is. With the propene, I don't need to do that. If we look back at the propene, it was attached to the first carbon. Now you might be saying to me, but wait a second, you could do this. You could do a single and a double like this. And you're right, I could do that. But look, if I number the carbon, this would now be the first carbon. And these two here, whether it's one there or one there, would not matter because it would still be on the first carbon. The general rule is that when you have but or higher, you need to number where the double or triple bond is. Now you might be anxious for getting steps to name compounds, and let me show you some steps and how this would work out. The steps are, we can outline them here. Find the longest chain of carbons and circle it. Now this you have to be careful with because I can make the longest chain look like this. Very straightforward. Or I can make the longest chain look like this. The thing is that both of these are identical. I have 5 carbons in a row, or I have 5 carbons in a row. The difference is that I showed it as a straight chain as opposed to a chain that is kind of bent a little bit. And so that leads to, that leads to a difference between them. Now let's run with this example right here. So let's say that this was all single bonded carbons together. Once I find the longest chain, I can fill in the hydrogens, and we can put in with just lines to show hydrogens, each carbon forming a total of 4 bonds. It's important to note that carbon will always form 4 bonds. So if you're unsure about how many hydrogens to put in, you could always go and say, well, this carbon has 1 bond here, and then I need to add 3 more hydrogens to make it 4. If it was double bonded like this, then it would only get 2 hydrogens. And if it was triple bonded like this, it would only get 1 hydrogen, or 1 other bond. So now I have my 5 carbons in a row, 1, 2, 3, 4, 5. I go to table P for the prefixes, and I see that it is pent, and they're all single bonds. So this example would be pentane. So pentane. So now, if you're not sure about what the ending is, you can always look in table Q and figure it out. So when I go through and I look, I say, all right, here, they're all single bonds. It's going to end with ane. This is going to be pentane. Now what happens if I have something, hanging off of the side? Like, for example, here I have this 2-methylpentane. Well, here I would draw my pentane just like I did before. Now, it's telling me a lot of information here. It's telling me there's a methyl group, 1 carbon. Meth is 1 carbon. And it's also giving me a number. That number tells me where the carbon is hanging off of. If I number the carbon chain, this would be carbon 1, 2, 3, 4, 5. That means off of the second carbon, you could put it on the top or the bottom, there would be another carbon coming off of it. This would be then filled in with hydrogens. and this would be 2-methylpentane. Now, I also wrote here 3-methylpentane. Well, 3-methylpentane would start off also with a pentane, 1, 2, 3, 4, 5, but now I would count into the third carbon. 1, 2, 3, and here's where I would put my methyl group hanging off of it, and the rest would get hydrogens. So as you can see, I can tell the person where to put what's known as a side chain. Now the side chains, just so that we're clear on this, the side chains, and we can write this up here, the side chains normally don't go above 3 carbons. We could have 1 carbon connected to the main chain called methyl. We could have 2 carbons, which would be ethyl, and we could have 3 carbons, propyl. So let's look at some examples here. I'll try a couple with you. So what I do first is I find the longest chain and I circle it or highlight it. So here I'm going to highlight this chain right here. Then I see if there's any side chains. There aren't, so I'm just going to go and try and name this. So I count the total number of carbons, 1, 2, 3, 4, 5. I look in table P. Table P will tell me that this should be pent. I then look in table Q and see, oh, it's ene, because it has the double bond. So this would be pentene. Now, at this point, this is where things get a tiny bit challenging. You look at this and you say, does it need a number? Well, I know if it's but or higher, 4 carbons or higher, it does in fact need a number. And this would be 2-pentene. So there we would have our 2-pentene. Let's try one more. So if I go down here, this one's a little bit cramped, but I see and I try and find my longest chain. So I have 1, 2, 3, 4, 5, 6, 7. 7 would be, if I look in table P, hept. I look to see if there's double bonds. There aren't. Triple bonds, there aren't. This is going to be heptane. But then I notice off of this carbon right here, there is a methyl group right there. There's my methyl group. So I need to go through and try and name that. So this methyl group is going to be methylheptane. But now when I look at it, I say, well, I could put that methyl group other places. I need to number where that methyl group is. So I start counting carbons. I look at this and I say, well, I could put it on the first, second, third. It could be 4-methylpentane. But I also want to test both directions. So now it's test going in reverse. 1, 2, 3, 4. Wait a second. Doesn't matter where I put it. So I'm going to call it 4-methylheptane. When do you start numbering for these? Generally, I start numbering with the side groups when I have 5 or more carbons. Because when you have 4 or less carbons, there's generally only one possibility of putting a side group in a particular place. Once you get to 5 carbons, you have what are known as isomers, which we'll talk about in the next video. Those isomers are going to tell me that, hey, I need to put a number here because it could be in more than one spot. It's reminiscent of what we did when we did the naming with transition elements. We had to number the charge of the ion because there was more than one. Here we have to number where the side group is attached to in order to figure out which isomer it is. So please go ahead and try these next 3 here for our homework, 1, 2, and 3 on this page, and try naming A, B, and C here as well. All right, we'll talk about this in class. Thanks so much for watching.